Today in the AWS Developers Podcast, we are diving into Lambda, how it works behind the scene. We talk about the Lambda Runtime environments. Good morning. Thank you for downloading the AWS Developers Podcast. We are available every Friday in all good podcast applications. Good morning, good evening, whenever you are listening to this episode. We have a guest today. It's Maxime David, your SDE, Software Development Engineer in the Lambda Runtime team. It's a subset of the AWS Lambda service team. I guess we don't need to present AWS Lambda to our listener, but just in one phrase to be sure that everybody is on board with us. What is Lambda? And then we'll dive into the runtimes.
Yeah, hi everyone, and hi Sebastian. Thank you so much for inviting me today. I'm way too coward to bring my own definition of Lambda, so I will read the doc.
That's so the official way to do it.
Yeah, exactly. So the official doc says Lambda, it's run your code without thinking about server or clusters. So yeah, it's basically the idea of you ship code and you don't really think about the underlying infrastructure, so you don't worry about patching the OS, bringing your own SDK. We will be back to that a bit later, I guess. But yeah, it's basically the idea of you ship your code and you don't need to patch the underlying environment. You don't need to worry about which distribution you're running on.
Or even really install an environment. That's the magic with Lambda. I type my Python code and I click execute or run and it runs.
Yeah, exactly. And it operates at scale as well. So if you have a huge spike of traffic, AWS Lambda will take care of that for you. Mm-hmm. So it's really here to help you to accelerate your business. So you're just thinking about what you want to ship and you ship it. So you can really focus on business logic and not about the infra.
It's funny how Generation X and Z are taking that for granted when I'm in hackathons or workshop. You deploy to Lambda, yes, it's normal. You write your code, you deploy. But I have white hairs, and I remember the days where I had to install Linux from floppy disk and then patch it and then install Java or Python, and then it's a lot of work that the Lambda team is doing for us, and I love Lambda.
Well, I'm super glad to hear it. And yeah, that's true for hackathon. A lot of people are actually using like a function URL. So this is a feature that we released, I think, 2 years ago. So you don't even need an API gateway. You can really just ship your code. It generates a URL for you, and you can just invoke it, and boom, you have a HTTP endpoint ready in like less than 2 minutes. It's really crazy. Like to kickstart project, that's a very good tool. I think. Yeah, I'm a little biased, of course, but yeah.
And boom, I like your expression. That's the best way to describe Lambda. And boom, it works. The Lambda is 10 years old, but we continue to innovate. This is not the main focus of this episode, but can you highlight a few recent novelties on AWS Lambda?
Yeah, sure. So about the news, maybe my favorite one, as you may or may not know, I'm a strong advocate for open source. And last month, AWS released a GitHub action to simplify function deployment directly in your GitHub accounts, like in your GitHub action. So basically, you just write the handler function for your Lambda, and then you include in your workflow YAML file the AWS GitHub action to deploy to Lambda, and once again, boom, it's deploying directly on the cloud. You don't need a CDK, you don't need serverless framework, you don't need SAM. You just need 1 or 2 lines of YAML file in your GitHub action, and it will deploy your Lambda function.
Super cool. I guess we need still the secret, like an AWS access key and secret key. But beside that, it will do all the magic for me. So I don't need to install SAM or the CLI or anything like that.
Exactly, yeah. You can use obviously your environment variable as GitHub secret, or you can use OIDC. So I'm not going to go too much into detail, but there is authentication between GitHub and AWS accounts. It's called OpenID Connect. So if you want to do that, that's also doable.
That would simplify the CI for customer, at least for simple environment for sure. What else?
We can talk also about one very powerful feature which enables developer to debug function running in the cloud directly from VS Code. So you can add like a breakpoint, you can move forward, step backward. So it's really like live debugging from your IDE directly on Lambda. So it's a very powerful feature. If you want to use it, there's a little plugin that you can use from VS Code. And you will be able to
ask since years. I remember a very old conversation where customers said, "Hey, it would be super cool if I can put a breakpoint in my IDE and have that breakpoint in the cloud and have a remote execution step by step from the cloud." There must be a lot of magic there.
Yeah, it's of course a lot of magic, but it's really simplifying developer experience, and this is what we aim for. We also hear from the community about the complexity of testing it locally. You need some emulator, so we heard the community and we try to be better at providing more tooling from the community for the developer. So yeah.
And you're part of the runtime team. I said that in my introduction. So how would you define a Lambda runtime? Where my code is running? Okay, in the cloud, but more precisely.
Yeah, that's a very good question. Sometimes runtime can be exchanged for a different meaning. So I'll try to be clear. But what we ship is literally like a box, and in that box, the first layer is the base OS for latest runtime. Yeah, exactly. For latest runtime, it's Amazon Linux 2023, but for older runtime, it's Amazon Linux 2. So I will highly encourage customer and community to use the latest runtime. So that's the very first layer, so base OS. On top of that, we are adding some certificates to talk to AWS or like any HTTPS servers. On top of that, we are adding the runtime itself. So AWS Lambda supports Node.js, Python, Java, Ruby, .NET as well. But you can bring your own custom runtime. I'll go much into detail a bit later, but you can use Rust, you can use Go, you can use almost anything. You just need to conform to the runtime API. So that's the runtime part. And on top of that, for specific runtimes such as Java, Ruby, and Node, not Java, sorry, Python, Node.js, and Ruby, we bring the SDK as well. So for instance,
the
if you want
SDK?
Exactly. So AWS SDK is directly bundled into the runtime itself. So if you want to call S3, DynamoDB, CloudWatch, you don't need to import that library because we package that with the runtime for you.
It's a big zip that I don't have to include in my requirements, the TXT for Python or in my zip file. So it saves on disk space, it saves on bandwidth to upload the package.
Exact. So we provide that for you, and if you want to bring a very specific version of the SDK, it's always possible. So if you want to add that as a dependency, as a node module, as a Python package, you can also do that. That's
I guess sometimes customers need to do that because they need to run a very specific version, either to work around an issue or to have a new functionality which is not deployed yet.
Exactly.
So the base OS is always Amazon Linux 2 or 23. There is not so much choice there. And then you said a wide variety of language, but we also support multiple versions, like the latest minor, but also the latest major. And then the SDK for a couple of them. That's a huge matrix of possible version. How do you have an idea of how many runtimes do your team provide? Maybe not the number, but an estimation.
Yeah, that's a very good question. And to be honest, this is what excites me personally as an engineer in the runtime team. It's really the multiplicity of runtimes of version. As you mentioned, I think we started Lambda 10 years ago with Node 2 or Node 4 or something like that. And now we are about to, so now we are like Node 18, 20, 22, and 24 is coming as well. It's a lot of runtimes, a lot of major version. And for testing as well, we need to be extremely careful because every time we patch the runtime, and I guess we are going to talk more about that, we need to make sure that million of functions that a customer are actually using in production will still work because they're not touching the code, but we are going to hot swap the underlying infra that's the promise of Lambda. You don't touch the infra, but we touch the infra. So we need to make sure that by patching the OS, by patching the SDK, by patching the minor or a major version of your Node or Python and Ruby, your function will still work. So that's what we're doing in the team.
That's crazy. It means if I, as a developer, start a Lambda function with Amazon Linux 23, that's the default, Python 3 dot something, and if there is an update on Amazon Linux, your team will produce a new container image, a new image and you will change all the deployed Lambda with that operating system and that Python version.
Exactly. That sounds crazy, but this is exactly what we're doing. So obviously, we're not going into like 1 millisecond for every single Lambda function. We are very cautious about that. Unfortunately, I cannot really dive deep into the process of doing this, but you can imagine that since AWS has a multiple region, we are not going to deploy every single new runtime to every single region at once. We are doing like staggered deployments for a small region, biggest region. I can go too much into the detail here, but you can imagine that we are very slow on purpose to make sure that when we release a new runtime, exactly. So it's very interesting because reverting back is also extremely complex, because once you've exposed something to customer, if they are using it and we are going to roll back,
them.
we cannot remove, because let's say I'm using an updated version of the SDK and I'm using a new endpoint that have been added or a new function. If I revert that back, well, the customer won't be happy because no, the function is not defined anymore. So we need to be extremely careful about the surface area of what we're exposing into the runtime. And this is like not endless, but a lot of discussion internally about, do we want to expose this every single new library that we add? We need to be very careful about is this function public, is it protected, is it private? So it's really interesting.
It's like changing the foundation of a house without removing the house, or changing the engine of a plane while you're flying, and everybody enjoys and nobody notices that. Of course, there is no magic. You're not changing that for running function during the time the function is running, but it's when the function is done, you change the underlying, I would say, disk image for the container, roughly, or for the micro VM.
We can say that,
And next time the function is invoked, it will restart from a fresh disk image.
Yeah, we can say that, definitely. So obviously, if your function is actually running, so function can run up to 15 minutes in Lambda. If your function is actually running, yes, we're not going to swap the runtime. But for a new invocation, it's very likely that if a new runtime is available, a new version of the runtime, your function will use that runtime. Yeah. And if you look at the very first log line in your function in CloudWatch, the init log line will contain the runtime RN. So every single resource at AWS is identified by your RN. So you can have a look at this RN.
So that's a way to check if the RN change. It means it's a new runtime, even if it's still Python 3.7 something blah blah.
Yes.
The RN might change because the underlying operating system has been patched or Python itself or something.
Exactly. And this is very useful information for customer because 2 years ago or last year, I can't exactly remember when, but we released what we call runtime management control, which allows customer to specify like, okay, for this function,
to pin a version.
Exactly. For this function, I don't want the Lambda team to be responsible for my runtime update. I want a manual update. So, or I want to pin to a very specific RN because I know my Lambda function is highly critical and I don't want to take any risk. Of course, it's very unlikely because we are doing a lot of tests, but obviously, it's very unlikely, but it's possible that your function will break because we're doing something or the customer is using something that has not been documented and we're removing it or upgrading it and it's not working anymore. So it's possible to pin back the function to a specific RN.
You said that you will not disclose too much details, but I'd like to know a bit more. Tell me if the question is acceptable or not. Roughly, what's the time frame to update the planet with a new runtime? I said the planet because we have 38 regions with a customer running Lambda function everywhere. So are we talking in hours, in days, in weeks, in months?
From the time where an image is ready to be deployed from the very first region to the very last region, we can talk about days. So it's not months, it's not minutes, but it's about days.
A couple of days, okay.
Not a couple of days, but days.
Days. Okay, days. You said days, I said a couple of days. And I guess you're doing these deployments every day and multiple deployments in parallel, because we have multiple versions of Java, Python, different types of vulnerabilities in the operating system to patch. So this type of deployment, it's business as usual for the Lambda team.
As you mentioned, we have multiple runtimes, Java, Python, Node.js, and those trains are totally separated. So we can start one train for Java, but not for Node.js. It really depends on what we want to ship. The most critical thing that we ship that overrules everything is CVEs. So as soon as we have a CVE, so a critical vulnerability exploit, I hope this is the right acronym. I always use CVEs. I'm not even sure that this is the right one, but you got me. As soon as a CVE is fixed, we need to patch the runtime as soon as possible. And as you mentioned, since we have a lot of tests, we need to be very careful about deployment. We need to start that as soon as possible, not to delay too much the CVE patching. So that's for managed runtime.
So for example, if there is a CVE in the Linux kernel that affects Amazon Linux 23, you're going to get the patch from the Amazon Linux team or the updated version from Amazon Linux. And then from there, you rebuild all the software stack required for Lambda.
Exactly.
You run your test and you roll out the deployment train that will take days.
Exactly.
To reach all customers.
Yeah, that's totally correct.
And I guess this is fully automated.
If I want to be fully transparent, we are aiming this to be fully automated. We are not at here yet, but that's what our team is working on, because everything that is fully automated will allow us to move even faster to production. Yeah. So
that's a continuous integration chain.
Exactly.
Of hell. I mean,
how
many pipelines you have in different, and it's running all the time and in different stage.
You can imagine the matrix, like every single major runtime, every single enum, like we have like node 20, node 18, node 22 times 6, because we have .NET, Python, Ruby. So the matrix is huge, and every single time that we change one line, one char of code, we run the full test suite again, just to make sure that everything looks good. So that's the magic of our team, I would say. We need to run all of those tests, this complex matrix of testing.
And if I understand well, your team responsibility is not to do that; it's to create the tools that helps you to do that. I mean, what you're building are the tools to automate all that.
Yeah, exactly. The less manual work we're doing, the better it is, because of course we are going to support more runtime, more families. So every time we add a new combination to the matrix, if it's manual, that's the nightmare for us. So we're really moving toward like a fully automated way.
What's the deliverable of your team? Because you say it's a runtime, but physically what it is, it's a disk image, it's a zip file.
Yeah, that's a very good question. So we have two kinds of artifacts. The first one is OCI image. So I didn't mention that, but when you deploy a Lambda function, there is actually two ways of deploying it. You can just provide the code, so a zip file. Can be containing Ruby files, jars, Python files. So that's the first one, and you will be hosted on what we call managed runtime. So this is the one that we fix, that we patch CVEs and all the process that I've described before. So this is managed runtime. The other one is OCI image. And this frequency of deployment is way faster because customer needs to pull the latest image and build that on their behalf. So we are not affecting, of course, we are affecting customer, but not live production. So if they have sufficient tests, they pull the newest image. If it's not working well, they can fix it. There is no magic here. If you want the new image, you need to pull it and rebuild your Lambda function. So the other artifact is pushing OCI image, and this is way faster for us to fix CVEs and stuff like that. So OCI is a second kind of artifact that we ship.
OCI is interesting because of that, many customers think that Lambda runs inside Docker, because OCI is the Docker image, what you produce with a Docker file. And actually, no, here it's just a container, a way to represent a file system on disk. And it's like when I say container, maybe I should not have used that word because of Docker, but it's just a file system image, basically, with the
exactly.
layers and things like that.
Yeah, it's a way for us to have access to customer code. It's a way to transfer code to us. OCI has been the chosen way.
But this means that if, as a developer, I choose to package my Lambda function as a Docker image, as an OCI image to be precise, it means you're not going to patch it for me?
Exactly. So
Okay.
if you release OCI, if you are based on OCI, we cannot hot swap the node version because you are in control of that.
Yeah, we don't know. You don't know what's in my OCI.
Exactly, and we don't want, and we don't have access to it. Exactly. So of course, security is one of the biggest concerns of AWS. We don't have access to customer code. So if you want to install a specific version of Python that has been totally deprecated, well, we won't encourage customer to do that, but if you want to do it for some reason, you can. So, but obviously we are not going to patch that.
You mentioned that, I mentioned that AWS Lambda exists since 10 years, and you mentioned at the very beginning it was Node 4 or something like that. I guess we don't support these runtime anymore. So at some point in the life cycle of a runtime, your team will decide to deprecate them. How does it work?
Yeah, exactly. So one responsibility of our team is also to deprecate oldest runtime. This is fully documented. If you go to Lambda Runtime, there is a very comprehensive schedule about that. So it happens in two steps. The first step is you cannot create new function. So let's say node 16 has been deprecated, I think. So you cannot create a new function. If you want to create a new function, it has to be node 18, node 20, or node 22. And then I think it's 60 or 90 days later, you can check on the fully documented schedule. You cannot update the function anymore. So if you have a running function, if it's running, that's perfect, but it's very high risk because now if you need to do a quick change, that's not doable. So we block function update as well. Function can be still invocable. So if it's running, it will run. But if you want to touch it, that's not possible anymore. Fortunately, if you move from node 18 to node 20 or node 20 to node 22, we are making our best to make sure that the migration path is almost fully transparent. So except if you're using like very specific feature from the runtime, it might not be possible to do that. But for most part, I would say I don't have numbers, but you can hopefully just switch from node 18 to node 20 and it should work. Of course, you should test it, but that's what we're trying to aim. If we are making a huge breaking change, we document it publicly. So for instance, from node 22 to node 24, we are thinking about removing callbacks. So if you look at the GitHub repo, we are opening an issue to, hey, this is our plan. What do you think? Because we are listening to the community as well. We need to move forward and to stop supporting like very old way of doing stuff, but we also want to listen to customer to say, okay, if no one wants to deprecate that, maybe we are going to reconsider.
And you're notifying customers months in advance. As a developer, I receive emails saying, hey, in 1 year this will be deprecated. You should start migrating.
Exactly.
And it's really region per region. So I guess you're analyzing what customer have what function deployed with what runtime, and you're sending them very specific emails saying, in that region, in that account, you have a function with node 16.
Yeah, that's correct. Yeah.
That's the type of email I receive on a monthly basis. And you're right, most of the time, at least for Node.js and Python, it's just a matter of changing one line in my infrastructure as code, CDK or SAM, and just redeploy, and most of the time it works. Hopefully you have a great CI/CD with a lot of tests, and you can just, as you mentioned, just bump the version of the runtime enum, and if the tests are passing, well, it's very likely that you can ship that safely. I'd like to come back to something. You mentioned that there are two different ways for developers to deploy their Lambda function: zip file that comes on top of a disk image that your team provides, and full disk image that we ship as an OCI image or a Docker image. What execute these these image? Are we using EC2 underneath? I know there is something called Firecracker. What it is?
Yeah, so you're right. Lambda is based on EC2 compute, and on top of that, we are installing Firecracker. That's not directly on my team, but that's on the Lambda team. And Firecracker helps for fully isolation between customer. Of course, when your Lambda function is starting, we don't want to share the memories, the disk space from a different customer.
Or even the kernel, yeah.
Exactly. So Firecracker is really helping for a fully isolated environment. That's super important for security standpoint. Yeah.
It's a micro VM. So each Lambda has its own kernel and is fully isolated from the neighborhoods.
Yeah, exactly. It's running on a very isolated space, and this is to make sure that we cannot cross boundaries between two functions. They cannot share memory. They cannot have access to the page of other memories of other functions. Sorry. So yeah, this Firecracker is. Oh, by the way, it's fully open source. So if you want to know more about Firecracker, if you want to contribution are very welcome. It's open source on GitHub.
And it's written on Rust, like many security sensitive part of AWS. It's
exactly
more and more these days. It's a fun project to play with because you can start a micro VM in just a few milliseconds. It's super quick, but these micro VM are super isolated. They don't have much device exposed to them, just the network. So don't expect something like Docker. It's very, very, very different. You don't have the same convenience if you play with Firecracker directly.
Exactly, and that's one of the challenge that we face and customers are facing as well. Serverless needs to start very fast because cold start duration needs to be small. So cold start happens when the function does not receive any traffic for some period of time, or like a very huge spike of traffic. We need to spawn more instance. So the first invoke will experience what we call a cold start, and we're aiming for this cold start to be as little as small as possible, and because we are operating into an isolated environment with low CPU constraint, with low memory constraint, we need to be very careful about what every single line of code that we ship is performance tested. We need to make sure that, okay, if I load this package, it takes 10 milliseconds. If I load this, so can we lazy load if the customer is not using it? Can we postpone the loading of this package? So this is extremely interesting, and we are working a lot with profiler, with memory and CPU profiles, so to understand really what is happening when a Lambda function is starting. And this is like a crucial part of our job as well.
So far, you talk about the managed runtime that your team produce and test and distribute and deploy. But you briefly mentioned custom runtime as well. What is a custom runtime?
Exactly. So managed runtime is really, you don't think about how to receive, because Lambda function is an event-based compute function. So you need an event to wake up your Lambda function.
Like
an
event
API
gateway call, an SQS message, or something that changed on DynamoDB or S3.
Exactly. So if I put an object on S3, I can wake up a Lambda function to say, hey, resize my image or add some tagging or you name it. So this event needs to be pulled from a queue inside your Lambda function. We need to treat this message and then send the response to the customer. So this is done by what we call the runtime API. So the runtime API is implemented by our team in Node.js, Python, Ruby, and etc. If you want to bring your own custom runtime, let's say Swift, let's say Rust, it's possible, but you need to implement yourself this runtime API. For some runtimes such as Rust, Swift, Go, we provide a library for you to do that. But if you want to run a custom runtime in Bash or in COBOL, that's doable. I would not encourage you to do that. But if you want for some very specific use case to write a custom runtime, that's doable. You just need to conform to the runtime API, which is very well documented on the Lambda
It's a
documentation
very
website.
simple HTTP-based API. Like you need to get the next event process. You give that event to the Lambda handler function that the developer provides. You take the result and you post the result or an error back. I think there are only 3 calls, maybe a bit more with error reporting, but the API is super short. And you're right. And actually, it's in the doc, and I tried that. You can write a Lambda function in Bash. It's just a while with a curl to get the event. You process the event, and then another curl to post the response.
Yeah,
for learning, it's really good.
Yeah, it's infinite loop to call /next. /next will give you the next event in the queue, and then you need to post the response or post the error. Basically, it's like many 3 API, and as you mentioned, there is an init report error and stuff like that. But for the main process, it's /next, success, or error. That's it.
And your team manage these for Java, Node.js, Python, and all the managed runtime. But then there are a couple of open source custom runtime as well. I think Go is one of them, Rust, Swift for the most known one.
Yeah. Exactly, and even I'm very glad that you asked this question, but even for the managed runtime, we are in the process of moving everything to open source and to synchronize and to be fully transparent about what is currently running in your Lambda function and where is the code for that. Because there is nothing secret. We are shipping, as I mentioned, OCI image. So if customer wants to dive, Docker dive or Podman dive into the OCI image to understand what is in there, well, we want to simplify this to the customer, and they just can go to GitHub and they can check, okay, what is the Node.js runtime? What does it look like? Can I open an issue? Can I propose a change request? That's entirely doable. And actually this week, I don't know when this podcast will be released,
somewhere
but we
in
created
September. We record beginning of September. So this week it's beginning of September.
Okay, awesome. So if you go to the public Lambda documentation, there will be a page exactly listing all the open source repository and how we use them. So we're trying to be more and more transparent about what is in Lambda and what is exactly in the runtime.
Oh, there is a very popular one that I forgot to mention that has millions of calls per day, per week. It's PHP, a very, very popular custom runtime maintained by the community.
Exactly.
As well in open source, you can run Laravel application inside the Lambda function.
Thank you for mentioning that. Actually, PHP is maintained by one of AWS heroes, and it's Mathieu Napoli. So I don't know if you're hearing this podcast, but thank you so much for what you're doing for the community. So AWS Heroes is a community of AWS elected. I'm not sure we want to go into that.
and Mathieu maintains also the Breath PHP framework. So have a look at that if you're a PHP developer. What keeps you awake at night? That's my last question. I mean, what are the main theme your team is working on? I know you're not going to disclose details about roadmap, but the things you're working on to improve the way you deliver the custom runtimes, the runtimes in general.
So personally, what keeps me awake is, as I mentioned, the fact that we hot swap the runtime without the customer actually realizing it. It's great feature for the customer because they don't need to think about the underlying infra, but it's a huge responsibility for us. How can we be extra sure that we are not breaking anyone? I think we are in very good position today, but I'm sure that we can go further into analyzing what could go wrong. So we are doing a lot of project in that extent to make sure to be one step further to be extra sure about, okay, if we do that, it will be good for our customer. So that's really the biggest challenge of the runtime
for your team. Yes, I imagine that at scale with you're not going to give any numbers, but with the hundreds of millions, maybe billions of Lambda function that runs on Lambda, that's a huge responsibility. So next time you as a developer, you will deploy your Lambda function, just realize, because that's not something that is obvious when you start to use Lambda, realize that in between two invocations of your Lambda function, maybe it will run on a completely different operating system and the full software stack, the foundation libraries, the language runtime, and even the AWS SDK. We change that under the scene every time there is a need to fix a vulnerability, for example. And that's the job of your team and the Lambda runtime environment Thank you, Maxime. Maxime David, your software development engineers in the runtime team for AWS Lambda. Thank you for your very clear and passionate explanation about that. If you've never developed a Lambda function, just try today. Pick up your favorite language. There is tons of docs and examples. And Amazon Q developers and other tools can help you to get started very, very, very quickly. Thank you for having listened to this episode until the end. See you next week in all good podcast application. But now, go build your first Lambda function.